Hello everyone and welcome back to yet another video. Today I'm gonna talk about mobile top 10 vulnerability classes and I'm gonna explain each one of them. So why am I doing this? It's because I'm starting a new series where I'm gonna go over each one of them and basically just talk about them, show you examples of how to exploit them, because they are the most common bugs on mobile applications. And as we can see, there are 10 of them this list was created by OWASP, and as you can see, the new list has been updated in 2024 and the old list was in 2016. And if we look at this chart, we can see that basically all of them are moved, or they are new or merged from one category to another. And we can see that this list is quite updated and the old list is old, and the new one is like the bugs that are occurring nowadays on mobile applications. So in this video I'm just gonna go every one of them, and in later videos I'm gonna explain each one of them in depth, and I'm gonna provide you with examples from vulnerable applications, and I'm gonna show you how to exploit them. So the first category is improper credential usage, and if we click on it we can read everything about it. And so M1 is basically the most exploited and the most common vulnerability class that there is. So this vulnerability class, which is improper credential usage, is basically that in mobile applications developers often leave hard-coded credentials, and basically we can just use publicly available tools to harvest these credentials and basically just log into application or gain authorization to some admin panels or something like that. Now, if we were to go ahead and read this, am I vulnerable to improper credential usage? We would see that they are categorized pretty simply for us. So basically these are hard-coded credentials, insecure credentials transmission, insecure credential storage, or weak user authentication, right? So basically these are all the ways that improper credential usage can occur, and in a later video I'm gonna show you probably each one of them and how can we exploit them and how can they be mitigated. And of course here's how do I prevent all of these vulnerability classes. So if you are a developer, you can just read how do I prevent and reference to this to secure your application. So the second one is inadequate supply chain security. So this seems quite complex, but basically what it is that some malicious third party or some insider gets access to application source code and basically modifies the source code so it includes a malware or some code that is doing harmful things. Or the more common exploitability of this issue is exploiting third-party libraries that are imported into application. Because if you just think about it, getting access to source code while the application is in development is not really a common thing that could occur. And the most common way for this vulnerability class to be exploited is by modifying third-party libraries that are being imported into application through, for example, website or something like that. So if we can compromise these third-party libraries, we can probably control the application and inject some malicious code into it. This vulnerability class is not really that exciting, so let's just move on to the third one. And it is basically insecure authentication or authorization. So this vulnerability class is pretty straightforward. It means that the application fails to successfully authenticate or authorize users, and basically what it means is that you can bypass authentication or authorization in some ways. And if we scroll down here, am I vulnerable to insecure authorization, authentication? We can see all of the methods that could be exploited, and most common of course are IDORs, because IDORs are like the top vulnerabilities that are occurring. Companies really frequently fail to secure their endpoints from IDORs. So definitely IDORs are one of the main focuses here. Of course, we have hidden endpoints, user role permission transmissions. So basically, we can see that developers might leave some endpoints that are not properly secured, and they would lead to authentication or authorization bypass, which would lead to a theft of like customer data, or be bypassing some things like paywalls or something like that. So the fourth one is insufficient input-output validation, and basically what it is that characters that you are inputting to application are not being escaped, and for example this might occur to cross-site scripting attacks or SQL injections or even command injections. So these are pretty hard to exploit, but they could be very bad for the application, because if you were to find a command injection, well, you can just compromise the entire device that the application is running on, and it would be very bad for the exploitability, and we are definitely will go over this issue here. So moving on, we have insecure communication. So insecure communication, let me just wait for the page to load. Insecure communication is basically application failing to securely implement protocols like SSL or TLS while making some requests to website. And basically, if an attacker is on the same network as the victim who is using the application, attacker can intercept the traffic of the application and steal things like credentials or PII, which is just customer data. Like for example, if they are submitting their credit card to some application, attacker can steal the credit card because the application failed to implement secure transmission of the data that the victim is providing to the application, and attacker can exploit this very easily by just being a man in the middle. The next exploit class, the next vulnerability class is inadequate privacy controls. And basically what it is the same as some previous ones. They are being repeated in my opinion a little bit, but inadequate privacy controls is like exposing PII via some things like insecure communication, which we just covered, and we can see how do I prevent inadequate privacy controls, or actually am I vulnerable to these inadequate privacy controls. So basically they could be the PII data could be harvested from insecure data storage and communication, as you can see here, data access with insecure authentication or authorization, which we already covered, which was the insecure authorization and authentication, and insider threats on the app sandbox. So this is pretty straightforward, is just compromise of the private data of a victim. The next one is insufficient binary protections. Basically what it's saying is that the app can be reverse engineered, and on the app there could be found things like secret keys, API keys and stuff like that, which can be exploited by just compromising the API application or making a lot of requests or something like that. Or of course we can just find like hard-coded password and we can gain access to something. You never know, every application is different. So basically what is insufficient binary protection is that the application hasn't been obfuscated enough, or and basically there is actually no way to defend against this. You can just obfuscate your application. But it is basically saying that an attacker can exploit this by just reverse engineering the application and then getting access to the source code, where an attacker could find things like API keys or any secrets, and an attacker can gain access to certain functionalities or certain applications that they shouldn't be allowed to access. Of course, this could also lead to bypassing, for example, paywalls, because an attacker can find a way in the application to bypass the paywall by reading the source code, and that would be a bad scenario as well. The next one is security misconfigurations, and it's basically any misconfigurations of security on the application, and most of them we have already covered. For example, lack of secure communication, weak encryption or hashing, improper access control. So this is pretty straightforward. I'm not gonna stop on this, but yeah, it is on the 8th category of this list. The 9th one is insecure data storage. This is saying that the application is storing some data on its storage, and that storage is not secured, so an attacker, if gained, for example, access to the victim's phone, can easily export this data, or an attacker installing, for example, let's see, Trojan on a victim's phone can just take all the data from the storage and gain access to data of a victim. And the last one is insufficient cryptography. And insufficient cryptography is basically just when we reverse the Android application, we can find some cryptography being used in it, and if it's not secure, and if it's not a proper cryptographic algorithm that is secure, basically an attacker can reverse the process and leak stuff like decrypt sensitive data, as we can see here, or manipulate cryptographic processes. And we can see that it is a pretty big category here, though it's not that common as the other ones, but it is on the top 10 list as well. So that's it for the 2024 list, and for 2016 I'm not gonna cover them right now. If I see success on these videos that I will be making on this 2024 list, I'm of course gonna cover these, because some of these are still very exploitable in the wild. For example, proper platform usage is found a lot, and a lot of companies want you to test for these vulnerabilities as well. And yeah, while these vulnerabilities of course are the most common ones, they are not the only ones, so just keep that in mind. And when we just talk about them, not just if you want, you can just, if you're doing bug bounty, you can just go ahead and look for every one of them based by like your liking or your proficiency in them. But of course, if you're doing the full penetration testing of the app, don't only refer to these ones, be aware of all the other ones. And so yeah, I think that's going to be it for this video. I hope you enjoyed it, and I will see you in the next one. Goodbye.